So on this video, this is going to be for homework 261 to 266. On this first problem, they want us to enlarge this by a scale factor of 4. And we always need to know where this dilation is coming from. And it's coming from the origin with a scale factor of 4. So I'm going to take each of these points and I am going to have them be 4 times further than they were. So this point here is 2. So it's going to go out to 8. So this is 2, 4, 6, 8. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8. And on the other side, it's going to be the same because it's 2 away from the origin. So that's going to be 5, 6, 7, 8. This one here is 1 away. So now it's going to be 4 away. 1, 2, 3, 4. And then my top one is 1, 2, 3. So it's going to be 12. So 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can connect. Oops, not a rectangle. And there's our figure that should be 4 times bigger than the original. On 62, the ratios that Casey had wrote for part A of problem 258 are ratios of the lengths of the corresponding sides of the two shapes. Look at the similar triangles below. Which sides correspond? Okay, so I'm going to color code. So 15 is going to correspond with the 6, and the 20 is going to correspond with the 8. And how you can check that is that across from that angle is the 15. Okay, and across from this one is the 6. And across from this double angle here is the 8. Is the 20, and then across in the other one is the 8. Okay. So again, 15 corresponds with 6, 20 corresponds with 8. Okay, right ratios for the corresponding lengths. So I can go 15 over 6, and I can do 20 over 8. Now 15 over 6, I can divide by 3, and I get 5 over 2. And 20 over 8, I can divide by 4, and I get 5 over 2. So you can see that we have the same ratio. Calculate the length of the hypotenuse of each triangle. Is the ratio of the hypotenuses equal to the ratios you found in part A? So if I'm doing Pythagorean, okay, over here, this is going to be a 10, but I can do 6 squared plus 8 squared equals c squared. That's going to be 100 equals c squared. So square root of that is going to be 10. For the other one, I know that for this one, it is going to end up being a 25. And how I'm coming up with these real quick is I know a 3, 4, 5 right triangle. Okay, that's one that you want to kind of know. Notice that the other one, if I was to double, would be a 6, 8, 10. And then if I was to times the 3, 4, 5 by 5, I would get a 15, 20, 25. That's how I'm thinking about it. But again, we can do 15 squared plus 20 squared equals c squared. And I'm going to get 225 plus 400. So I'm going to get 625. And so that is going to be a 25. That's what C is going to be, 25. And then they're asking about those ratios. So if I'm looking at these ratios, the 25 and the 10, and we want to see if they are the same. 25 over 10, I can divide by 5 and I get 5/2. So you see they are the same. So yes, the ratios are the same. Describe a sequence of rigid transformation, a sequence of transformations. The word there is not rigid because these are not congruent, that map one triangle onto the other. Okay, be specific. So what I'm going to do is probably the easiest way to do this is I'm going to move the 90-degree angle of the bigger triangle. Okay, I'm going to translate it to the right angle in the other triangle. So first thing I'm going to do is I'm going to translate vertex of, so the vertex at the right angle of larger triangle onto corresponding vertex in smaller triangle. When I do that, they're not going to be the same direction. So the next thing I'm going to do is I'm going to then rotate the larger triangle until the side of 20 falls on the side of 8, because that's the corresponding side in the other triangle. And then what I'm going to do is I'm going to do a dilation at that vertex. So then at that, at the, I'll just say at that vertex. And the vertex I'm talking about is the one that I marked in blue. We're going to dilate. And since I'm taking the bigger one onto the smaller one, I'm going to actually dilate it not by 5/2, by 2/5. Okay, because I want to make it smaller. So if the sides are 5/2 going one direction, it's 2/5 going the other direction. On 64, we want to figure out if there's an error here. Now, what I'm going to do is I'm going to look at that 9 and I'm going to see, is that possible? I just chose that side. I could have chosen any of these 3 sides. But if I'm choosing the 9, then I'm going to take the 3 and the 5 and I'm going to add. I'm going to also subtract. And what has to happen is that 9 has to be in between those 2 values I just got. And it's not. So the side needs to be, I should say the 9 needs to be between 2 and 8, and it's not. The next one is a right triangle, so I think I'm going to use Pythagorean theorem, because just looking, if I add 5 and 12, I'm going to get 17, and if I subtract 5 and 12, I'm going to get 7. So 14's in between that. But I'm going to do 5 squared plus 12 squared, and I'm going to see if I get 14 squared. So I'm going to get a 25 plus 144. The other side's going to be a 196. This is going to be a 169. The other side's a 196. So that is not true. So it does not satisfy Pythagorean theorem. And this one over here fails triangle inequality theorem. So on the next one, I notice I have a 7 and a 7, which means it's isosceles. And if it's isosceles, that means that this is going to be a 65. Okay, so that is by isosceles. Now, let's see if that makes sense, because if I take a 65 plus a 65 plus a 55, does that equal 180 degrees? So 65 and 65 is going to be 130. So I'm going to actually end up with 185. So this is going to fail the triangle angle sum theorem. On 2-65, we're going to be doing the diamond problems. So I'm trying to figure out 7 times what multiplies to get a negative 98. So if I take negative 98 divided by 7, I get a negative 14. And then I'm going to add those, and that's going to give me a negative 7. On the next one, I'm going to multiply those together, and that's going to give me a 9/4. And then I'm going to add them, which is going to be nice because they do have a common denominator. So I get a 6/2 or 3. Let me just rewrite that. So 6/2, which equals 3. On the next one, I want to figure, what do I multiply with a negative 5/2 to get a 5/4? It's going to be a negative, and it's going to be a negative 1/2. It's going to be a negative 1/2. That's going to give me a positive 5/4. And then when I add, I'm going to get a negative 6/2, which is a negative 3. On D, what can I add with negative 10 to get 0? That's going to be a positive 10. And when I multiply those, I'm going to get a negative 100. And let's take a look at the last problem, 66. So on 2-66, top of the charts, Renee's MP3 player can be programmed to randomly play songs from her playlist without repeating a single song. Currently, Renee's MP3 player has 5 songs listed, loaded on which are listed at the right. At the moment, she only has time to listen to 1 song. Okay, so let me just, so she's got 1, 2, 3, 4, 5 of them. Is each song equally likely to be chosen as the first song? Yes. And that probability, since there are 1, 2, 3, 4, 5, is 1/5 for each. What is the probability that her MP3 player will play a country song? So let's look at country songs. So country, this is country, country. So country is going to be 2 out of 5, 2/5. What's the probability that she will listen to a song with mama in the title? Okay, so mama in the title. 1, 2, 3. So it's going to be 3 out of 5. What is the probability she listens to a duet with Hank Tumbleweed? Okay, so a duet with Hank Tumbleweed. So here's a duet. That's 1. Okay, and looks like that's the only one that's got Hank Tumbleweed. So that is going to be 1 out of 5. What's the probability she listens to a song that is not R&B? Okay, so I'm going to look at the ones that are R&B. One is R&B. So that means that the rest of them, which is 4 out of 5, are going to be not R&B. So what I did was I used the idea of, if I know all of the probabilities together added up are going to always equal 1. And so if I know what I don't want, which is 1/5, then I can figure out what I do want. Okay. Or I could have counted up the 4. And that's the end of this video.